Okay, so today we're going to be talking about extreme values of a function. Okay, so extrema, we're talking about maximums and we're talking about minimums of a function, which are really important, especially when we're talking about economics or business, because when you're talking about profit, to maximize profit, you need to minimize cost. So if there's a way of looking or finding these absolute extreme values to better increase our financial profits, we definitely would want to know how to do that, right? So let's find out how to do it easily on a quadratic. So find the absolute extrema of f of x on this closed interval from -2 to 3. So following our steps, step 1 is to find the derivative. So f prime of x. So you're going to use chain rule. So we got a constant multiple, then we have a function inside of a function. So the derivative of the function inside is 1 times the derivative of the outside, which is the power rule, 2 x minus 2 to the 1 power minus the derivative of 3, which is 0. Okay, so it means our derivative is basically 4 times x minus 2. Now, to find our interior extreme values, or critical points, we set our derivative equal to 0. And that means that our critical points are at 2. So next step is, once we have our critical points, finding the coordinate. So plug into your original equation f of 2. So when you plug in 2, you get 2 minus 2, which is 0, and you get -3. Now, because we're on a closed interval, we also have to check our endpoints. So we're going to plug in our endpoints. -2. When you plug in -2, you're going to get -2 minus 2, so it's 2 times -4 squared, which is 16, minus 3, which is 29. And then the other endpoint at 3, you're going to get 3 minus 2, which is 1, times 2, so 2 minus 3 is -1. Okay, so looking at these, this means that at -2, my height, my maximum height, is 29. So this is our absolute max at -2. Now the other two are the minimums, but what is the absolute minimum? -3. That is our smallest value. So that is our absolute minimum. And if you looked at the graph of this, basically at -2, you're up here at 29. At +2, you're at -3. 1, 2, 3. And at 3, you're at -1. So it's basically a quadratic that looks like this. And you can see with graphing it very quickly that this is your absolute max and that's your absolute minimum. Okay? But algebraically, we have to find the derivative, set it equal to 0 to find our critical points, which are our interior ones, the horizontal tangents, and then we check the endpoints. Now, graphically, finding absolute extrema is much easier. So when we look at this, we can tell which one is our absolute max and our absolute minimum. But this one right here at 2,7, this is a local minimum. At 314, this is a local max or relative max. This is also a local maximum, and this is also a local minimum. But we're looking for the absolute, and so between these two maximums, which one's bigger? At -2. So this is our absolute maximum. And out of our two minimums, which one is the biggest or the smallest? So this is our absolute minimum. So graphically, it's really easy to see where our biggest function or biggest value is and our smallest value is. All right, and then the last part, finding critical numbers. Okay, so we're finding critical points. Now it's not asking us to find extrema, it's just saying finding the critical numbers. So again, to find critical points, you find the first derivative. So f prime of x, that is 3x squared minus 6x. you set it equal to 0. To find the solutions, you factor. So you start with your greatest common factor, which is 3x, which leaves you with x minus 2. So our critical numbers are x equals 0 and x equals 2. And again, f of 0. So we plug in 0 and we get 0. And then we plug in 2, f of 2, which is going to be 8 minus 12, which is negative 4. So you can see that 0 is going to be higher than 2, so 0 is probably a maximum and 2 is a minimum. Not absolutes, but definitely maximums and minimums. Now, if you use some of your pre-cal background, and we looked at the graph of this, we have 0, 0, and we have 2, 1, 2, 3, 4, 2, negative 4. Those are the points that we're using. Now also, if you factor your original equation, you get your zeros at 0, which we already have, and positive 3, which is a 0. We have an odd function with a positive lead coefficient, so we know on the left side it goes down, and on the right side it goes up. So graphically, we know this comes down, crosses here, comes back up, bounces off the x-axis there, and then comes back down. And I know it bounces at 0, 0 because my multiplicity is 2. Even powers bounce, odd powers cross. And now that we have this graph here, you can clearly see our critical points, this one being our relative maximum, and this one being our relative minimum, because we do not have absolute maximums or minimums because we're on an open interval. Okay? So just make sure that when you're doing these, that you're answering the questions that they're asking for. Now, they didn't ask us to find maximums or minimums, it just asked us to find the critical numbers. So basically, we could have stopped right there. Our critical numbers are 0, 0, and 2, negative 4. Okay?